a short term or an acronym that we actually coined from this long title of the project, End-to-End AI and Data Systems for Targeted Surveillance and Management of COVID-19 and Future Pandemics Affecting Uganda. This project had 3 specific objectives. So objective number 1 here was to strengthen the data systems, resulting into usable and equitable data sets. So one of the ways to diversify our data sets was actually to collect data from radio and understand what are the issues affecting the communities that are being discussed on these radios, and how can we be able to take that feedback and give it back to the government and so on. The second objective was on automating diagnosis of COVID and the others. The third objective was on how to aggregate all these different data sets to actually inform government response. We're able to execute the work by organizing the project into 4 work streams.
The undertaking that the team has done is very demanding in terms of data. So this again, ladies and gentlemen, underscores the importance of data. And I say data is now the new gold, because without data, there's not much you can do, particularly when we are talking about artificial intelligence. So thank you so much, Tim, and colleagues from the different institutions. You've been very, very instrumental. You've made a lot of input. We thank those institutions that provided data on COVID-19, others, like you've seen in the different work streams, provided data that helped the different work stream leaders to do their work.
The radio workstream, our main objective was to mine text and audio data to understand community perceptions on COVID-19 from radio. The specific objectives being collection of radio data from central, east and northern regions. So some of the work we've actually done is building baseline models and coming up with models that no other researcher has actually built before. That entails building speech-to-text models for Acholi, Luganda, Lumasaba, and also the other specific objective has been to analyze radio data to understand people's perceptions on COVID-19. Our key outputs were speech-to-text models for Acholi, Luganda, and Lumasaba, a radio monitoring dashboard. Here we're able to actually deploy various devices across these regions, and we're in position to stream radio data from community radio stations, because there are people who are actually in the communities whose voices will never be heard except if we try to dig down and reach out to some of these regions. So we're able to build a human evaluation tool and then COVID-19 radio analysis dashboard. We've also released some open source data sets. So looking at the gender aspects in relation to the radio workstream, we realized that women participated more in the morning hours, and the men participated more frequently than women in every hour we try to analyze.
There is a gender gap in artificial intelligence. One, in terms of representation. Some of these statistics are not disaggregated. You cannot know who is there and who is not there. And if we are also talking about race, how many blacks are there? So the overrepresentation of men in the design of these technologies is historical. And it is actually being mirrored in artificial intelligence itself.
This is the mathematical model that we developed. We wanted to use local data. For example, in the top left corner, we have air quality data. Then down there, we have radio information. And then we have mobility information, regards to movement of people. So these are the parameters that I'm talking about. You can loosely call them model inputs. And so for example, we have parameters like the disease transmission rate. We also went ahead and did statistical models. So we put the results and the modeling predictions in a dashboard, which is available via web interface. Because of the data we got from the ministry and other partners, we're able to analyze gender aspects in relation to this work stream. And we're seeing that men were testing more than women. And this was actually probably reflected in the COVID-19 cases that were being observed. You can see here, men were infected than women. It could be probably because the males were testing more, but also to be actually that COVID-19 affects men than women.
We found out that women had better health-seeking behaviors than men. Another key output was the model prediction amongst people living with HIV. And it is showing in the dark green area around here, those people who were predicted negative and they are actually negative. And here it is showing the false negatives. Down here is showing the false positives vis-a-vis the true positives. Another key output was a decision support system. And here we are having a page of one of the people that we've tested with the system. And this person is having a risk of being with COVID-19 of about 87%. This tool is within Call for Life. And here it is showing particularly where you could find the page, because this is not only for the decision support system, but it collects a lot of data about HIV patients. So here is the form where it is found deployed within the system for Call for Life.
We in this work stream thought it wise that let us try to come up with a machine learning approach to aid in the diagnosis of COVID-19. So the key output, we have already achieved data collection. Here we obtain both public data set and then local data set from which we collected from Lago and Kirudu National Referral Hospitals, of which we found that more men were so sensitive to testing compared to female. The next key output, we found exception model performing much better compared to the rest of the models which we have so far trained. Part of the dissemination which we have already achieved is that we had a conference presentation in AI for Health. We also exhibited during COCOSI's Open Day event.
The chatbot is usually a much more specialized and customized platform. As you know, or may not know, but I think most people in this room would know, ChatGPT is based on an aggregate of data that is out there on the internet. It aggregates all that data and then digs into that data and then gives you a response following some models. The idea behind the chatbot is that individuals have a platform that they can call that is scalable because they can call any time of the day. And the way it works is that you ask a question which at the first level comes in as text, and that text is processed at that second level where you have the question mark. The bot, as we call it, tries to understand what you're asking. We've had about 135 full conversations. And so these are some of the conversations that we've had both in Luganda and in English. These are publicly available. Other developers can use them, and they're both in English and in Luganda. the voice models, the text models, and then of course the chatbot, which I just mentioned.
I think each stream has provided novel results that can be very useful to improve our health outcomes in Uganda. So I want to see many of these. You had the objectives, you saw their output. They have demonstrated to us good models and outcomes. As an academic, I am particularly excited that you have 4 publications in 2 years. With that, I wish you well. I thank you for coming. I thank the team for doing very good work, quality work, and I hope we can build world-class results. And some projects in our college have already put us at that level. So let's continue the effort to change the world in terms of research that informs decisions. Thank you so much.